put the announcement. Okay, for midterm exam, it is under stack. Okay, understand?
Okay, sir.
Okay, question 40 MCQ. Alright. Okay. So our topic today would be on Q. Okay, on Q. So the topic is very similar to stack. Okay, Q tak masuk midterm lah. Alright. And then is the topic is quite similar to stack. So basically the lecture will be quite short lah. It's not quite short lah. It's shorter than stack lah because you already learned the basics in stack. So what is Q? Q, the analogy is like you queue in a bank. The first person that comes in will be the first person that will be served. The concept is basically first in, first out. Then how is it different than stack? Stack got only one pintu, right? Remember I say got one portal where everything happens. Add or delete, all push or pop, all happens at the top, correct? Remember not? But Q, there's two pintu, front and back. Because you can ingat the concept is first in, first out. Okay, so for the programming, you need to refer to your textbook. Okay, so you're gonna learn about queues. You're gonna look at the various queue operations, how to implement queue as an array and linked list. But the implementation in C++ is inside your textbook. Then we look at queue applications and become aware of the standard template library for the class queue. Alright, so this is example of queue lah. Alright, so when you add a person in this queue, so this one is for example at the bank lah. When you keep new persons come in, it will add to the back of the queue. Okay, but the person that's already inside, the first one that is already inside will be the one that will be attended in. So that's why it's called the concept. The concept is called first in and first out. So the first person that comes in will be the first person that goes out. Alright. So there's two doors here, front and back, or we call as rear and front. Okay. So to stack, everything happens at the top or the door. But you see queue here, got one door you masuk, got one door you keluar. Alright. So that is the basic concept. So queue, like a stack, is a data structure as well. Alright, everything must happen at the rear and at the front. At the front, when we add in element, it happens at the rear. Okay, remember, add in element, it happens at the rear. And then anything that's being removed happens at the front, what we call as DQ. Excuse me, yeah.
Sir?
Hello? Okay. Alright. So here, stack everything that happens at the top.
Sir, we can't see your slide.
Yeah. Wait. Okay, can see?
Yeah, I can see.
Alright. So you see stack, everything happens at the top. But queue got two parts. Rear for add, front for delete. When you keep on adding things, so the rear will move lah on top. So ni rear, keep on moving. Okay, dia akan pergi ke belakang. Okay. The front here would delete lah. Okay, so there's two doors. So what are the basic queue operations? So you initialize a queue, you destroy a queue, check whether the queue is empty or is it full, add in data into the queue, remove data from the queue, what is called as DQ, return the front value of the queue, and return the last element of the queue. Queue, you cannot straight away the one in the middle. You must use the front door and also the rear and the front, and queue and DQ. Okay, remember that principle. Okay, so how you implement a queue? Sama macam stack, same like stack. One is an array, the other one is a linked list. Array static, linked list is dynamic. Okay, you can keep on adding the data. All right. So that's why it says implementation of queue as an array, it must be a fixed size queue. All right. So if the application does not requires a fixed size queue, then use array. Simple solution. Else use linked list. Okay. So in order to implement a queue using an array, you need these four elements. Array to store the data, a variable, that represents the front, a variable to represent the back, and a variable to represent the maximum size of the queue. Okay, so you imagine this is the queue. All right, so this is the array. Okay, so I jumped one slide in front just now and I'm going back. So how does queue front and queue rear works? All right, so okay, so here you want to check if queue is empty or full. All right, so just to give you an idea, queue front is the index of the first element of the queue. Queue rear gives the index of the last element in the queue. All right. So if you want to add an element into the queue, queue rear, you're going to move to the next array position and then you add in the element. If you want to delete an element from the queue, you retrieve the queue front, okay, and then you move the queue front to the next element of the queue. All right. Okay. For a full queue, the value is queue rear is equivalent to max queue size minus 1. If size is 100, then the index should be 99. Okay. Now, queue, how do you know if the queue front, sorry, how do you know if the queue is empty or not? Okay, so we got two questions here. How do you queue front and queue rear? Okay, just now you looked at how queue rear indicates that the queue is full. All right, that means queue rear value is the same as maximum minus 1. All right, for queue front, okay, this one we're going to look later on. Okay, so now this one you just keep inside your mind first. All right, about this queue front here. So queue rear we already answer, add in element we already answer, delete element we already answer. Okay, so here's an example whereby you add A. So you add A, you put queue rear at 0. You add in B and C, see the queue rear moves. Okay, now it's at index 2. Front still kekal. Front is only invoked, okay, when you want to delete. So when you delete, okay, then you see queue front move to the next index. So that's the basic principle of queue, right? Now a little bit difficult, not difficult, a bit confusing. See, with queue rear, okay, near the data 97, 98, 99. Okay, so the last data is at queue rear 99. So here got data, here got data, here got data. So a lot of delete queue happen now until queue rear, queue front here becomes at 97. Okay. Now, what is the problem with this one here? Here actually, see, because queue front already moved until 97, here actually empty. But queue rear already 99. So queue rear is actually equivalent to max queue size minus 1. That means the problem here is that this is actually still have a space to put in data inside the array. However, it says that the queue is already full. Because why empty space? Because queue front you already moved until 97. You understand or not? Can you see that? And then queue rear pula sudah full. Dia cakap sudah full. Sudah sampai kat belakang, but queue front is at 97, meaning all here empty because you already do a lot of delete queue. So how do you solve this problem? Okay, there's two methods actually. 1 and 2 here. Alright? Method 1 is basically check value of queue front. If there are basically empty spaces in the queue front here, so all of these, all this data from front until this one, all the populated data, you're going to slide it back into the first array position. But this one works if the queue size is small. Okay. However, if the queue size is not small, then you implement using a circular queue. Alright. So advance the queue index to queue front to delete an item. So queue front to delete an item, queue rear also to insert an item. So how do you make a circular queue? You need a special formula now. Alright. So this is the formula that you use to implement queue as a circular array. Okay. So you see here, queue front is 98, queue rear already 99. So this one is already full stack lah. Conceptually. But actually in reality, there's a lot of empty space here. So how can you still add in Z? Using circular array, right? Implementing queue as a circular array can. What happened is that the next Z is going to be put here at index 0. Okay. So how does this work? See this one. So you see if queue front, so you need to use this formula here. So if queue front is 98, queue rear is 99. Alright, so 99 plus 1 modules by 100. So queue rear would become at 0. Okay, so add in a value happens at queue rear. So queue rear add in 0 at index 0. Okay, any questions before I move? Everyone okay?
Still okay. Conceptually still okay.
Conceptually still okay. Just that remember like this one, implementation queue, circular array, have to use this formula. Okay. If not, use this algorithm here. If there's empty space, slide the data or the data here, you slide back to the front of the queue. Alright. Okay, so this is the mathematics basically. So if queue rear is less than maximum queue size minus 1, right? So this is to see if it has empty space, right? Then queue rear plus 1. So if here plus 1, then here plus. So here, excuse me. So if queue rear is less than maximum queue size minus 1, then if you queue rear plus 1 here, it will be less or equivalent to max queue size minus 1. Alright. So queue rear plus 1 remainder by max queue size, you can dapat value queue rear plus 1. If the queue rear points to the last array position, whereby queue rear is actually equivalent to max queue size minus 1, then queue rear plus 1 is actually, because here is plus 1, so here you put plus 1, so it's equivalent. Alright, so queue rear plus 1 modulus maximum queue size is actually equivalent to 0. So as you see the example just now, you get 0 here, alright, which is the first array position. This implementation, right, this implementation got problem. So what is the problem? You see, queue front, okay, assume queue front has a value x here at 98. Okay, queue front dekat 98 at the value x, queue rear is 98. Alright, so if you delete queue, okay, that means queue front is 99, queue rear is 98. So when you delete this one, means nothing lah here, right? So it's an empty queue. Now here, all get the x1 here all got data. So queue front is at 99, queue rear is at 97. And then you add in data. So what happens when you add in data Z here? Queue front still 99, but queue rear you increase by 1, so it becomes 98. Alright. So what happens here? These two scenarios, one empty queue, the other one is full queue. So this one is the opposite of the other, but you see the value of the queue front and queue rear, it is actually the same. Okay. So how do you solve this problem? So this obviously cannot be the same values, right? Because it's two completely different scenarios. Alright. So solution 1, you keep a variable count to count the number of the items in the queue. So you increment count by 1 when you add in element. You decrement the value of count when you remove an element. Alright? And then the initialize function and destroy queue, you set when you call these two functions, you will initialize the count to 0. Alright? So this solution is very useful. You need to know the number of elements inside the queue. You have to keep track the number of elements inside the queue. So this is one way. Alright? So that you don't have this issue anymore. Alright? So if you use a variable, then you know lah how many values are actually inside the queue, the array. Okay, whether it's 0 or it's 100. 100, why? Because range starts from 0 to 99. Huh? This is one example. The other one is basically you make a reserve area or reserve slot for that matter. Okay, so the thing is with reserve slot, if the value is maximum, the size supposed to accommodate 100 elements, you can only put 99. Because why you need this reserve slot, right? So queue is empty if queue front sama dengan queue, but you see when you have a reserve slot, okay, if this is an element, you need to keep this place here as a reserve slot. Okay, so when you keep on adding value, all right, at one point it will reach here. Okay, so it cannot put any value inside the reserve slot. All right, so queue is considered full if the next available space is a reserve slot. So that's how you know is it empty or full. Okay, if the next you want to put in a number and then the next index is a reserve slot, okay, that is full. It is empty if queue front is equivalent to queue rear. Alright, so these are the two different solutions. So for the implementation, please refer to your textbooks using count, which is solution 1. I think solution 2 is also inside the textbook. Alright, so that is implementing queue using linked list. Next is implementing queue as in array. Next is implementing queue in a linked list. Alright, so you're going to have two pointers, queue front and queue rear. Alright, for linked list, queue is never full up. Alright, so you can keep on doing NQ and DQ. So front of the queue will point here, rear will point this one here. So you can keep on adding at the rear. So you add in a new node, alright, establish this link to the new node, and then you move the rear. If you want to delete a node, front, you need what you need to do is this front, you need to remove here. Okay, then you can delete this pointer by having another pointer pointing towards it. Alright, so this implementation you can look at your textbook. It's quite similar to step. Alright, so basically the class, container class, basically get the size of the queue, check whether the queue is empty or not, right? True if the queue is empty, false otherwise, push an item inside the queue, get the front value of the queue, get the back value of the queue, and then remove the next element inside the queue. Alright? However, there exists some special, not special, I wouldn't say special, some a situation, right, whereby there needs to be a priority queue, like your Asia, a priority seat, alright, or at a hospital. Because you see, like hospital, right, people register at the hospital, and then when there's an emergency, you need to attend to the person first. Okay, so that is the concept of priority queue, alright. So how do you process item using priority queue? Alright. One way, there are basically two ways. In linked list, keeps item in order from highest to lowest priority, and then tree-like structure. So tree-like structure we're going to cover later on. Alright, so we're going to look at what do you mean by highest to lowest priority. So what can happen is that when you put in data inside the queue, alright, you can see that the smallest data you put to the front. Alright, and the bigger the data, you put to the rear. That's one way. So that means you're going to have a comparison lah. So when you put data inside the queue, okay, see first. If it's smaller than the previous number, okay, then it goes to the end, to the front of the queue, else it goes to the rear. So this is an example as well lah. The bigger number, you are going to put in front of a queue, and then you're going to dequeue it straight away. Alright, so basically you make a comparison first before you add in into the queue. Alright, so here you're basically going to use a less than operator. Alright, so the concept queue is very simple. Alright, so concept is based on first in, first out. When element is removed from a queue, where is it removed from? Enqueue or is it dequeue? From dequeue. So the queue removes from where? From the front. When element is added to the queue is enqueue. Alright, it's added at the rear. So what are the two operations that all queues perform? See whether the queue is empty or full, for example. Enqueue and dequeue. Alright? Any questions? So for queue, the main concept is actually, because the implementation is the same as in stack actually. Alright? Just that it has few different scenarios here. Okay? What happens, because it uses two doors here, front and rear. You must ingat, this front sometimes it gives the impression that it is full, but actually it's not full because you already moved the queue front. So you need a solution whereby two solutions lah. Either you slide or you use a circular queue. But when you use a circular queue, also got a little bit of scenario that you have to two exceptional scenario whereby you have to solve. There exists a situation whereby empty queue looks like a full queue. So in order to solve it, you've got two solutions as well. One of them using a variable count. The other one is actually to use a reserve slot solution. Okay, no problems. Okay, no questions. That's all for today. For the implementation, you can look at your textbook and then you can straight away do your lab. All right. So your midterm, as I said, it's I've already given the dates. The topic is until stack. There are 40 questions. All right. The question would be random. There will be also, if you have your internet connectivity problem, okay. So the question is online actually, basically. But however, if you got internet connection problem, then you download the offline method. Okay, you do the offline method. All right, but you need to take proof lah that you have you have internet connectivity problem. So what happens is that at the start of the exam, okay, you just download the offline exam question first. All right, if you can do online, you do the online. If you got internet connectivity problem, then you have to take proof picture showing your router is still on and then your internet is nothing there. Okay, and then you contact me via WhatsApp. I'm going to create a WhatsApp group, okay, for your midterm. Then I will post the link to join my WhatsApp group inside the ELIP. Okay, and I want everyone to join. You must join. If you got problem, you must at least WhatsApp me, and there's my number there as well. So if you cannot WhatsApp, internet totally down, then you call me. Okay, is that clear?
Yes. Okay.
Clear? All right. Okay, that's all for today. I'll see you guys at the lab this week. Bye, everyone.
So
Thank you, sir.